computer. Hey, welcome everyone to the Utah Microservices meetup on 25 August 2022. Big thanks to LiveView Technologies for giving us the room here to meet tonight, and to Omni for providing the food. Yeah, that rocks of both companies. So let's do introductions again until I get anonymous feedback that's like, you know, I keep going if you stop the introductions, but let's do it. Let's start with our online folks today. Jed, you're first on my list here that's not in the room. Would you like to introduce yourself, like who you are, where you work, that kind of stuff?
Apparently not. He's unmuted, maybe?
Yeah.
Or maybe he doesn't have a mic?
Possible.
Can they hear us?
Yeah, he's showing that he's on mute.
Yeah. Jed, we have you on mute.
Oh, sorry about that.
No worries. Cool. Yeah, want to just give a brief intro to yourself?
Oh, sure. Sorry, I was going to grab a beverage. So my name is Jed Schneider. I work for a company called Highwing. We have a sort of invented architecture on AWS serverless primitives. It's sort of glued together with Ruby code. So we do a lot of eventing, but we don't do any event sourcing. So I'm sort of starting to just get into this, and appreciate you putting it together.
Awesome.
Also, I've read your book, Ethan.
Oh, well, thank you. Always sparks joy to hear someone make the distinction between evented and event sourced. So that's great. Thank you. Welcome, welcome. Peter, you're next on our list who's not in the room.
Sure. Hi, everyone. I'm Peter. I work at a company called Irwin, where we use event sourcing to load some financial data. I have some exposure to Eventide, but it's always good to learn more about it. Let's do for the last meetup for the doctrine of useful objects, and that was pretty enjoyable. So looking forward to this one.
Great. Thanks for coming. Nicholas Henry, you're next on the list here.
Yeah, good evening, everybody. Yeah, I'm a self-employed freelance software developer. I currently develop my choice of technology currently is Elixir. I was brought up, I guess you could say, on Ruby on Rails. I guess I've sort of been shadowing Eventide for a few years. Ethan, I've read your book. That was a big influence for me. I've really kind of learned a lot from the community. I have not used Eventide in a production setting, but boy, have I learned a lot from this sort of community by sitting on the sidelines. Yeah, so I'm sort of very happy to be here. I wasn't able to meet live in the last meetup. I saw the recording. Yeah, there was a lot of good information there. So happy to be here.
Awesome. Thanks for joining. Going by your accent, I'm going to guess you're not in the Mountain Time Zone.
Yeah, it's actually a little bizarre. So I'm originally from New Zealand, but I'm actually in Montreal, Quebec. So I'm a little closer than you would expect.
Okay, right on. Well, thanks for joining us.
Yeah.
Let's see, going down the online list. Juan, want to say hello and introduce yourself?
Yes, sure thing. My name is Juan Lopez. This is the first time that I've joined this meeting. I just joined because I follow Ethan on Twitter, and I've been looking at the Eventide repos, and I've been quite interested in learning a little bit more about it. Yep, that's pretty much it. I'm a cloud architect at an enterprise company.
Right on. Thanks for joining. All right, we can switch to in the room now. Azul?
Close enough.
Okay.
I am Atul. I work at LVT and identity and access stuff.
Right on. Cool, thanks. Ethan, co-organizer of this meetup. I work at Omni, on the hat.
Casey, I work at Wilson Sonsini, and I guess I'm sort of a co-organizer. I just pester Ethan to get stuff done, really, as it comes down to.
So nothing's changed.
Yeah, that's about it. So,
Hey, I'm Swapna. I work with LVT as a software engineer.
Troy Thomas. I also work at LVT as a software engineer.
Previn Menon, software engineering manager at LVT.
Tyler Ray, I'm the infrastructure manager.
Connor Whitfeld, I'm on the DevOps tooling team.
you want to hit Nadeem out?
Hey, Nadeem.
Nadeem Nazir in the management. Thank you.
Roy Hayward, I manage some software engineers.
Jerry Brainer, I'm at LVT as a software engineer.
And I'm Eric Moffitt. I've been at LVT for 3 weeks, and I'm a software engineer too.
And the man of the hour, Scott Abbott, who will be presenting tonight. I'll butcher it, so I'll let you
Yeah, like Ethan said, I'm Scott. I've been working for LVT for 4 years. Started out in QA, automated testing, and some of the front end functional testing. Moved on to web development for a handful of years, and just recently transitioned over to helping out with DevOps and the infrastructure and tooling side of things. We here at LVT have been doing Eventide. We're ramping up into it. I am one of the first people at Eventide or at LVT to have started using Eventide. So I have me and Casey over there. We had the most experience with it at this company, which is only about maybe a year, if you want to be generous about the amount of time I've been working with it. Yeah, so today I'm going to be talking.
Scott, can I interrupt you before you get into it? We had someone else join. Letitia, we were just going around and introducing ourselves. Would you like to introduce yourself, who you are, where you work, and so forth?
Sure. Hi, can you all hear me okay?
Yeah, you're coming through great.
Okay. I'm Letitia. I work at Wilson Sonsini, Goodrich, and Rossetti as the product development manager for Neuron. We're using Eventide to build out Neuron.
Awesome. Thanks for joining. Cool. Now, Scott.
Cool. Yeah. So as the slide says, we're going to be going over testing with Eventide, components, controls, that kind of stuff. This is going to be fairly high level. It's going to be mostly looking at the process of testing in general, and then looking at it through the lens of Eventide. I'm not going to go super in depth about the actual implementation details of event sourcing, components, the actual library itself. We've gone into detail with that stuff in previous lessons. We're going to go into more detail a little bit later. And we can save that for when we do the practical portion of the meetup today. So jumping right into it, the things that we're going to cover, TDD, that's my preferred method of testing or methodology. Going to go over what it is, why to use it, go over testing a component. We're going to look at the account component, Eventide's primary example, the one that I go to most often. That has a bulk of what you're going to be doing when you first start out. Like 90% of your use cases are going to fall somewhere inside of the account component. And that's where we're going to dive into what controls are and whatnot. And then we're going to do a bit of a practice session where we take an event model and we try to follow TDD and create something very similar to what I show off in the slides. The kind of tests that you would do with that component example. It's going to be more like a breakout session. So you're going to be pairing up or grouping or whatever, or individually for those online and attempting it. I apologize for anybody online who isn't very familiar with Eventide because it's a pretty hands-off little demo repo. It's not going to give you a whole lot of instruction. So it's going to be a little hard working through that, but we'll make our way through it. All right, so test-driven development.
Why? Why would we use test-driven development? It's not rhetorical. Anybody can answer. Why? What may be some good things about test-driven development? Or if you don't know what it is, you can ask that too.
We can write the exact code what we are aiming for.
Write the exact code you're wanting to from the start, sure.
The behavior.
Kind of building around what it's going to be used for rather than trying to like engineer things around it.
Yeah, that's a good point.
We can detect breaking changes.
Yeah, you can get some good code coverage because you're testing from the start.
Yeah, we can prove that the code we're writing does solve that it wasn't working before, and then you write the code, and then you prove that it does work.
Yes, you have meaningful tests. They're not just tacked into there at the end.
I think it's also nice. Oh,
sorry.
It's good documentation as well.
Go ahead.
What was that? Sorry, didn't quite come through.
Oh, sorry. It's good documentation too for the
documentation,
the actual code. Yeah.
Yeah.
I like to think of them as it's mini science experiments.
Yeah.
Like it puts my science mind of having the hypothesis and then the test and then the results.
And, it can often remove the anxiety of getting started.
Fair, yeah. So you guys hit some of the points that I put on here. You know, when you're doing TDD, you also get the benefit that you're writing your code with testing in mind right from the start, as opposed to just writing out a bunch of code. At the end, it might not have a good way of being testable. Fortunately, with Eventide and what we did with the doctrine of useful objects lesson last time, we showed how that dependency injection and stuff like that can make it easier to test components and whatnot. It was mentioned before, test the documentation. Get confidence in refactoring your code because you can make changes and still see that it's functioning. Only the code you need is written, right? Because you're following along and making it so that you own, we'll get into that in more detail. And at any given time, you can say that your code was functional very recently, within like a minute or so. That one is really powerful to say that I could take this and I can ship it. I might not release to customers, but I could deploy it and it would work even if it's not finished. And to say that all it would take is maybe a couple times pressing Control Z or Command Z to get back to a working state if your partway isn't there. What might be some negatives to TDD? Because there are. Everything has pros and cons.
Extra time building the test, I guess. Not very much, but plan it out.
You have to maintain your test too.
Yep, you have to maintain your tests. It's a lot of extra tests. It's a slower startup because you are having to go through testing and writing the tests before you actually write code.
The criticism I've heard is the sort of evolutionary design of what you're building that TDD would encourage to you isn't good. Better to sit down and design the thing up front before you start trying to write test cases.
Yeah, there's no solid evidence saying that it is better of the design to start with TDD than to not.
Still have to keep the big picture in mind, right? So
some people may think the tests you're writing are acceptance tests or more proving out when there's more tests that need to be written sometimes. So sometimes it's really good, but then you need more than just the stuff you're writing from the beginning.
Yeah.
You can hide those.
So I don't know how many of you, go ahead on Zoom.
Oh, yeah, I was just going to say, yeah, they can often be an excuse for acceptance tests. There's this sort of idea of writing the software right and writing the right software. I think there's a separation between TDD and acceptance testing.
Yeah.
And then following on the science analogy, your hypothesis could be wrong from the start, right? Like you start with a wrong premise, you end up with a wrong answer, and then you get a production bug.
Yeah.
Yeah, so it could almost possibly give you a sort of a false sense of security in terms of what you're developing.
Yeah, that's fair. Those are all good things to keep in mind. We're going to move forward with the assumption that we like TDD, and we're just going to move from there. But it's good to keep those things in mind. I don't know how many of you have heard of Uncle Bob, but he came up with these 3 rules of TDD that I like to follow. You can't really go wrong when you're doing it, and a lot of TDD, if you're attempting it, will end up looking kind of like this anyway, if you're doing it right. So first one is writing production code only to pass a failing test. Now that just means don't start writing code until you have a test for the code. Write no more of a unit test than is sufficient to fail. So as soon as there's a compilation error or a function doesn't exist or you'd get a null pointer exception or whatever it is, you stop right that instant and then move on to writing the code to fix it. And that leads to the third one. You don't write any more production code than is necessary to fulfill that test that's breaking at that time, right? So if it's that the function doesn't exist, you write the definition of the function. You don't create the logic of the function, you just write the definition and then you move on and get the test to force you to make it work. Okay, so let's take a little more concrete look at what that actually looks like, right? So let's say that we have, we're doing a test for a function, like I was just saying, that gets the factors, a list of factors when you give it a number, right? The first step is to write a test. And this is a very basic bare bones test. We'll worry about the test structure, the library and everything. We'll get to that when we look at Eventide. Most people should recognize the word test and assert if you've done any testing before. So if this is all the code we had and I run this test, what would we expect to happen?
Factors of is not defined, whatever.
Yeah, we'd get an undefined method, right? And that's exactly where we want to be. We want the test to fail and for us to write the code to fix it. That's another thing that's key with TDD is making these assertions to yourself or these predictions about what's going to happen when you run the tests. Because the more you get in the habit of doing that, the more analytical or critical you are of your own code and trying to understand what it's actually doing, right?
And then, is it open to comments all throughout?
Yeah.
I really like the point you just made. You said that. I was thinking that, like, it's not necessarily that I want my test to pass. I want to understand what my code is doing. So if I'm expecting it to fail and then the test passes, like, that's not a happy moment. Like, I still want to, wait, why is this different than my understanding? And so
I actually had that happen today because I was using testing fixtures that I didn't know much about or hadn't understood very well. And so I was thinking, oh, this should fail, and it passed. And I was like, wait, why did this pass? This wasn't supposed to. Turns out the test fixture itself was testing something different than what I thought it was testing. But it was good to verify and like, oh, okay, yes, that should have passed. It makes sense now, and move on. And I've also had it pass when it shouldn't have, and that was because the test was wrong, right? Like literally. So anyway, I wholeheartedly agree with this. It's to verify it does fail.
Yeah. Okay. So we've got a failing test. What's the next step?
Write the code.
Yeah, you write the code. We write just the minimum amount to make it pass. Now, I kind of skipped a part a little bit. Like if you want to be really nitpicky, you would first write the definition, then you'd realize that, oh, it doesn't have the right number of arguments, and then you'd fix that, and then you'd realize, oh, it's not returning anything, so you've got to make it return something that has an empty method. And, you know, I mean, skipping a little nitpicky things. But at this point, we've got the function. It returns a list, like our original thought. What happens now if we run the test?
It works. I would guess it would work. Yeah, it passed.
Yeah, we get a success. We get nice green validation, get that dopamine hit in our brain. We're happy. Ship it. It's done. Now
take a nap.
Yeah. So from here, we've gotten a test. We've got it green. Again, it starts to feel repetitive, and that's the point. You get into this cycle. You get into this loop. The next point is you make another test. All right. And what do we expect to happen if you run both of these tests?
One pass, one will pass.
Yeah. Do we know why it'll fail?
It's not equal to 2. It's returning empty.
It's always empty.
Yeah, we'll get an assertion failure because it's not, they don't equal. Empty list does not equal list of 2. Right? Exactly. So then we go and we fix our code to do that. And the point is to only write the minimum amount, almost naively so, right? So you're letting the tests flow you into the right design. right? Instead of thinking up this big algorithm that can solve everything right away and then writing the tests after the fact. And as you keep doing that, passing tests, you write more and more and more tests. And at some point, you shouldn't just do this, the most naive approaches. You should get like that bottom test there, something a little more robust that more fully tests what you're actually going to go for. You end up with a streamlined or slimmer version of the algorithm that you wanted to fulfill all of those things. And you get that nice big long list of green tests. At least that's the idea. So that's what it would look like in a general sense.
If I might add a comment, maybe you're going to head that way, but someone said that your tests should start specific and head generic or something like that. And your code, the code should be specific to generic, and then the tests would be generic to specific or something similar. Like they had.
So your tests should be getting more and more specific, more and more granular, and your code should be more and more generic and care less and less about what inputs it's getting.
Right.
Yeah, exactly right. That's not quite what I was going to get to, but related. Not only are we getting our code out, but we're also coming up with the design. It's not good enough just to write tests. You want good tests. You want valuable tests, right? Oh, I see a comment coming in.
Somebody send us a link.
Okay. Oh, yeah.
So you've written a basic test at the very beginning, and then when you had your next thing, you're saying, okay, now we want to make it more specific. We left the first test and we wrote a second test. I do understand that you're wanting to leave some artifacts there so that if something changes and it breaks, you have a roadmap of where it broke. But it seems like this approach can leave lots and lots of tests that are all covered in the final test. Why wouldn't we make a test more complex to make it fail as opposed to writing a completely additional test every time?
This particular approach is kind of contrived and nonsensical. It kind of goes to the questions that I'm about to get to that make your tests smart, right? You're writing good, valuable tests instead of like just a bunch of little tests and eventually a test that actually is valuable.
So I will throw out a little bit that you want to make sure that when a test fails, you know what failed.
Sure.
And so sometimes when people blob things together, it's like testing 6 different things and you're like, wait, what actually failed, right? So just to throw that out there. And that I also will throw out that it's not against the law to refactor your tests afterwards, as long as you keep the same, functionality type thing. If you realize your test.
So you're saying you go ahead and you follow this, but then when you get to the end, before you ship it, you go like, okay, these tests are stupid. Let's get rid of it. This one could be combined.
Right. Conceptually, I've tested this concept with this other one, so this one doesn't matter as much or whatever.
Yeah. Refactoring is a part of the cycle, right? So
that makes sense.
Yeah. Okay. So there's a couple questions that keep me on track with designing while in testing. And the first one I usually ask myself is, what is it that I want it to do? Ultimately, what is the thing I'm trying to solve? Right? Whether that's a handler for something or a function, what is it supposed to do? And then immediately after, I ask myself, well, how do I know? How do I know that's what it did? This makes it so that you're designing it in a way where you can find out, you can make it testable, and you're also setting up the design to be exactly what you expect it to be at the end. So you're thinking critically about what it should be and not just writing up the code mindlessly. We'll get back to this. Okay, let's look at this more concretely in the context of Eventide, of testing a component. I told you before we were going to go over the account component. This is directly from the repository. I just pulled it down. Sorry for those of you who are in the back or can't see it very well. We can actually open it up if it would help as well at some point. But for the point of annotating and stuff, I left it in the slides and I can have fun arrows and whatnot. So this is specifically the test for the account component where you open or close an account. When you tell the component, hey, I want to open a brand new bank account, it gets to opened. If we start breaking the test down line by line, first thing we notice is this top section here with contexts. Well, that's because Eventide, especially if you use the generator, the basic thing it ships with is a test library called TestBench. And I personally like TestBench a lot because it is very light. It stays out of your way. You focus more on the tests rather than the library to test. So these contexts are more just like little wrappers to give you, well, context of what you're about to test. In Eventide, these contexts usually match directly to file structure in your tests, right? So you'll see there that it starts with handle commands. Well, we're inside of handle commands. The context is open. Well, we're dealing with the open command, and we're in the opened RB, and the last context in there is opened, the event that we're expecting to test for. This is the happy path. We're just going to focus on this one right now and deal mostly with the happy path. And maybe if we have time, we'll get into a lot of the other things that you want to consider while testing. But we're just going to break down this very simple but direct example. Okay. So getting into what is it that we want it to do? What is it that we want a handler to do when it receives a command?
Handle.
Handle the command.
The status of that. At any time. It's kind of the link between the command and who sent it.
Yeah. So we want to make sure that the handler handles the command and writes the opened event. In this case, the happy path is there's a brand new account, so it'll open an account as soon as it receives an open command. To start things off, we have this first section of the test. For those of you who are familiar with testing jargon and whatnot, these are your preconditions, your setup. This is the environment that we'll lead into before we actually run the handler and get into testing and finding out. With that, there's this little thing here that I promised at the very beginning that we would go over, which is controls. This is not something that you might find very commonly in a lot of other testing libraries but it's really not even unique to the testing library. It's more just a paradigm. You can think of these controls as like controls in science when you're doing a science experiment, right? When you're doing a test, you want certain variables to remain constant, to be the same every time you run that test, so that when something does change, you can directly say, that's what caused the change, right? And at the most basic level, that's all controls are in Eventide as well. It's an object or data that's set up to be a very specific value so that every time you come back and run that test, you get the same expected output.
A big part of the mindset shift with controls versus other things too is that in a lot of tutorials in software development that deal with tests, they have the examples that you're being used, the place of these controls taken, the Eventide test and so forth. In other scenarios, those values are written by the tester. And so those become a thing of the test. And the big, it's a subtle change, but a profound one. It's saying that no, if I'm the developer of some part of the system, providing examples of what the thing that I'm building look like, that's on me to do. If I'm doing TDD, I might very well be the person writing the test and the person writing the code. But examples of what the things are, that's not a thing of testing, that's a thing of just building something.
Kind of takes out the external things too, so you're not worried about what's coming in, just what you wrote. So, it's nice.
Yeah. Another thing to note is that controls are optional, right? It is a paradigm to use, but you don't have to use that control paradigm. You can set it up however you want to. It's your test. Were you going to say something?
No, Scott just asked, C1, he asked, why not just use a factory bot? No.
Okay. So what is this specific control doing? Well, it is getting a constant time that we know means something to us. We called it, in this case, they called it the processed time. That represents when an event was processed by the system. And we're taking that example time and we're putting it into the clock of the handler. If we remember the doctrine of useful objects lesson that Ethan did last time, the clock is a dependency that the handler has. And we're going to use a real handler that's set up with a time thing. So what we're doing here is we're telling the clock, here's what time you think it is. And then we have the actual thing that we want to use as input, right? The open command. It gets its own control. Now, even though it says controls commands open, really that example method is returning a real message that we would have otherwise gotten from the system. It's using the actual data object and it's just setting up with predefined values. And underneath that, we're saying, if any of those values aren't there, well, this test isn't going to work because we kind of need those things. It's a prerequisite of the test.
If you inspected the value of the open control that you get there, you wouldn't look at that and be like, this is obviously a test data. Like, unless you happen to know it came from the control file, you would otherwise assume it was a perfectly valid operational message.
Yep, that's right. The data in the controls are valid real data. I mean, if you've got a UID, it's probably a static or pre-generated UID, but otherwise they're real values that you would expect to see if the system was actually running.
Where is that populated from?
Where's what
The real
populated from?
information.
You create it. You either hard code it or, because it's a control, you want it to be the same every time. It's like hard coded values in a sense.
Because you're designing the system, you know what valid values look like and you can provide them.
Nathan asks a question. Welcome, Nathan. Why not just use time cop versus passing the time into the clock? For those less familiar with Ruby, well, I'm less familiar. I don't know. Nathan, would you care to, I could guess what time cop is, but I bet you could explain it immediately.
Is he muted or is he just not able to talk right now?
Chat it.
He is muted.
Nathan, could you describe what time cop is?
He's muted.
Hey, can y'all hear me now?
Yeah, you're coming through.
Okay. Time cop is a library that lets you set the time in your test so that when anything calls like time.now, it's the value that you set in your test.
So the reason for that is because we're not doing this only for tests. We're setting the time specifically to a specific time for the control for the test, but this clock is actually used by the handler itself. It's a dependency of the handler. And it's not calling clock.now. So we're just hooking into what the handler already has access to.
Perfect. Thank you.
Okay. My slides are a little out of order. I just realized. But the next thing after we've set up our preconditions, well, we do the actual thing. We pass in the data and we get to the next question is, how do we know that it did what we expected it to do? In Eventide specifically, they have this nice little library called telemetry. It's wonderful. I would recommend that if you're building stuff, this is useful for not just Eventide, but for any objects that you're creating. You can add this telemetry gem and inherit some of the functionality from it, and it lets you record the stuff inside of the object. It gives it some built-in telemetry. You can, as part of your function calls and stuff, say, hey, telemetry sync. Now you know that I've done this thing and I've done this thing and whatever. The telemetry is there to be useful for the object itself. It's not for the testing, but because it's there, our tests can take advantage of it and find out that it did what we expected it to do. So going back a couple slides to this, one of those things that inherits telemetry is the writer, the Postgres writer in the handler. As part of what it does, it keeps track of what events were called by the writer, or what data was passed into the writer to write to the Postgres database where your message store lives. And that's what this writer.one message is doing. It's going into the telemetry sync and fetching out the last instance, or the most recent instance that matches the predicate that you pass in. So in this case, it's a message or event that matches the type opened. We're checking, do you have one of these? If you do, give it back to me.
I just want to be clear. It is not actually hitting the database or anything like that. This is a substitute that is using that telemetry.
That's fair. Yes, because we're using doctrine of usable objects, we have a substitute instead of the actual object, but it's still useful and behaves very much like the actual object, except outside of making a real database connection. Which is why we, up at the top there, you can see we did handlers command .new so that we could get that substitute instead of a .build.
I'll ask the question this time. Why wouldn't I just use a spy for that?
Because then you're adding code into your objects strictly for the purposes of testing, and it becomes more bloated and whatnot. The telemetry is useful outside of the testing. It's a built-in feature of it. We're just taking advantage of it. So in our case, it's still more efficient to just use what's already there and it's available to us rather than adding a lot more work for ourselves strictly for the purposes of testing.
Yeah, in addition to that, I'd also say, like, if you use a spy now, the thing that's being exercised here is now this special spy you created just in your test versus the actual objects in use here. And like, I think I told the story the first one. I was working on this code base once, looking at the test that was passing, looking at the code that was ostensibly under test, and those were not the same thing at all. And so looking at the code, it was like, if this ever got exercised, it's going to crash. And so making heavy use of spies and mocks, you're not even testing your system anymore in extreme scenarios of that. And so if one of the whole points is to guide the design and to give us confidence that stuff is working as expected, well, then we need to be actually exercising the code that we're writing, not some unholy concoction of spies and mocks.
Stay inside of your system.
Yeah.
It's not necessarily mocks that are the problem there. It's the understanding of whether a mock is a noun or a verb. And so typically spies and what we refer to as mocks, mock behavior and not the contract, not the explicit contract. So I don't actually know how the Eventide library works, but there's a huge difference between using mocks as verbs and mocks as nouns in terms of the explicit contract between those two systems.
Could I challenge a little bit, and I only do that to better my understanding. We're still using a substitute, so that is not what's going to be working in production. Could you talk a little bit to that point?
I mean, that leads a lot into
I think a useful contribution to answering your question is something that Scott said in a chat message. Other Scott, you didn't.
Yeah, no,
Scott said testability is expressed in the object itself rather than spread externally throughout the test code. And so by localizing the testability within the object that's being developed, it's giving that object better cohesion for all the characteristics for it that we ought to consider. Your question is a good one, Nicholas. Also comes to my mind in that is, in this particular test, the writer is not the unit under test. It's not the thing whose behavior we're trying to validate right now. We're trying to validate the handler. If we were writing the test for the writer itself, we certainly wouldn't want to make a substitute for the writer.
If I vaguely remember, it is actually testing the same code that is, like, so the Postgres version is actually injected into the same, I'm trying to remember the code that the substitute is actually exploiting as well. So like this, the actual Postgres calling a database thing is like hooked into, I guess.
Okay, it's also a useful object dependency of the writer.
I'm trying to remember.
It's been a while since
I've been spelunking in that part of the code base, but I think it's a Nixon that actually uses the same logic. So you are something like that.
Is there a contract? Is there so there's this sort of idea of contract tests. I think I'm so sorry, I forget the name. It did a sort of great presentation on integration tests or a scam, but sort of promoted this idea of contract tests. And so is this this is a SPI where it's just sort of instantiated purely for that test. Is the substitute under a contract test that would verify the substitute along with a production object?
So there are tests for the substitute that it verify it behaves correctly under the contract to say it is the
okay.
thing.
Yeah.
We're not.
Yeah, so that would be very different to a SPI that has no tests that verifies how the SPI works. But if we have a substitute that is under test in itself, along with its production counterpart, that would give more confidence in terms of how that substitute that we have in our test.
I'd have to look again.
Like I said, the same.
It's been a while since I've splunked in that code part of the code base, but of Eventide. But I believe they do have tests to verify the same functionality, or the contract functionality. Anyway, but that's not what we're concerned about here.
But it's, yeah.
All right.
It's
okay. Yeah.
Just some thoughts on the on kind of like what Scott is saying. This is probably touching on the tell, don't ask principle too, right? Like it's you kind of want to test the abstraction, or I guess it kind of goes for the contract idea as well. But you probably don't want to use a SPI or a mock necessarily, because then you're kind of almost hacking it, right? Because you're kind of changing the implementation when you're examining it, and it's like, okay, this is what you should do, rather than just have a thing that works as it's supposed to. At least in front end, it happens a lot.
Yeah, and I think Nathan addressed this in the comments as well, where the substitute accompanies the concrete implementation. There's more of assurance there that the interfaces remain horizontal. And I think that's kind of a nice sort of point there, is that the substitute is actually provided within the library versus the SPI, where it can just kind of, there can be a drift in the contracts.
Scott Belray mentions that we have an approach to our contract testing that is a bigger subject for another time.
Yes, very much.
Nathan also says this is different from mock SPIs, where bespoke ad hoc configurations of mocks are implemented inside test code by the tester, who is not likely to be the same person who implemented the dependency. Building on the point he just made that the substitute accompanies the concrete implementation, the person writing the concrete implementation of the dependency is also writing the substitute, and they are very close to each other in the code. The examples in the Eventide repositories, you'll find references to the substitute in the quote main file of the dependency as well. So again, it's the substitutes that we need to use for testing to get this visibility into what we're doing. Are those a thing of test or a thing of the design? Is testability a first-class aspect of the design of what we're building? Hopefully. You'll probably experience less pain if you do that.
All right. Really good discussions.
That's great.
Yeah, no, that's really good. All right, so continuing this analysis of the open to opened test cases. Now that we have our telemetry, we can see into the writer, we've got our preconditions were set up and we executed the handler. Now it's about validation. We need to check if we got what we expected to happen. So we start off with checking if the actual opened event was written. Thanks to our telemetry, we can see whether or not it was. And we can also check that it was written to the right stream. That's something that gets a little bit more into the specific implementation details, but those are definitely key things you want to be looking out for when you're writing messages. A, that you wrote the right type, and B, that it wrote to the right place. In addition to that, we want to make sure that the output result in that event is predictable. It is what we expect it to be. So that's where those controls are directly checked. If there was some mutation, it's a consistent mutation to that data every time. So for example, the process time gets turned into an ISO 8601 string and put onto the object from the time that we put in, which was an actual time object. That's what the raw is from the controls. It's an actual time object. And then in the event or open, we expect a string that represents that time. So we validate that we got the right output there. Okay, so that's the basics of testing a happy path, right? Next thing I would like to go into, if everybody's open to it, is practicing this. Like I mentioned before, getting a little more hands-on. I have an example repository where I literally just created a component with the Eventide component generator, took out some stuff where it requires a connection to an actual database, threw in a couple placeholders for your messages, and snipped in an example event model so you know what data we're working with. And we can pull it down on individual machines and try hacking away at it. Let's get set up with that first. Apologies to the plethora of people who are online. You can attempt to go through it yourself. It'll probably be a little hard if you aren't really familiar with Eventide to execute some of this stuff without help.
Yeah, I know, I saw that.
Perfect. Thank you. Hipster.
Did something go wrong with that?
I spelled your name wrong.
Okay.
Wait, can we get this as a bit.ly or something? Come on.
I can.
I just dropped it in the
chat. Yeah, I was about to.
Thanks for coming, Letitia.
Thanks for coming.
Yeah, I could have grabbed that. I should have been more on top of that.
Where did the
we've got a YouTube channel for the meetup.
Oh, that's cool.
You can post it on the meetup.com thing. I'm sure one of these fine folks can also share.
Yeah.
Okay. Scott Bellware mentions that in version 3, guessing of Eventide, the component generator will be replaced with a straight up GitHub template repo.
Hey, Scott. Basically what we're doing.
Well, yeah, so here at LVT, we've taken the Eventide generator as a inspiration, created our own generator, and we're planning on taking the template that exists in that generator and moving it to an actual repository that has its own changes and whatnot, and the generator just like references that, pulls it down, and
pull those templates down. So it'll be templated.
Yeah.
It's great when someone doesn't update their local generator and then they get a really out-of-date template that they work on.
Yep. So, yeah. I can probably actually go to this and show off at least 3D, which is very basic. All right, so the goal is to create a happy path test that looks very similar to the test we just got finished analyzing. that takes, you have a warehouse component, it'll take in a command to ship a product with the various information that might be important to shipping a product, and then post an event saying, yep, it was shipped. We started that shipment.
I'm gonna post the install gems command into
Rust.
I don't want to anger people.
Scott says, I look forward to seeing whose community project template becomes the favorite. If I remember correctly, the one that you guys made has a lot of specifics to LVT's infrastructure.
Yeah,
so it's meant as an internal tool.
It's not going to be necessarily open to the community, unfortunately. Yeah.
Sorry. It has all our CI stuff and Terraform proprietary things.
Yeah.
Let's see if you.
I'd open source it if people were down.
Breaking some of that out. I think templating is the right idea, though. So it's good that.
You can do just dev instead of development if you want a little less typing.
Okay.
Mm-hmm.
Okay. Anything but production. Is there an option to do more typing?
Yes.
Yes, there.
Doesn't the install gem script ask you what posture you want to use?
No.
Oh, I thought it did.
If you put posture as production, it then doesn't, or no, I don't know. It defaults to.
Sorry, I'm taking
slowing down stuff.
taking this opportunity to actually display that
Could someone speak to the sort of the idea of a posture versus an environment?
Scott or Nathan, would you be willing to speak to that one? I confess that for me, it's. Go ahead.
We're both just sitting here like laughing at the fact that this has become the subject of the conversation. It's just a word we use because we don't like environment. Because environment doesn't really really like match. It doesn't have like a lot of not physical, but like mechanical sympathy. Hey, I'm talking here. You want to talk? You put on your headphones. I guess I'm gonna have to go stand next to Nathan. These are noise canceling. You have to speak up, old man.
Posture is analogous to environment, like Rails env. It solves the same problem, but it's a different mindset. Rails env is about what environment am I inside of. Posture is about what role am I playing as a human being operating. What am I trying to do?
Did anybody hear that?
That's in and out.
Nathan is actually on mute. I'm wondering if we're hearing it through your loop.
Yeah,
Scott.
unmute me.
Yeah, I was just saying that posture solves a problem it solves the same problem that Rails env
It's not
does,
mine.
like Rails environment, but it's a different mindset. Rails env is about what environment am I inside of. Posture is about what role am I the human being operating this thing? What role am I playing? Am I acting as a developer or an operator? In other words, it's oriented around what am I trying to do as the person who's invoking the script.
I think of it as what the computer's trying to do.
Yeah, fair enough. Yeah, that's what it is.
My laptop never goes to production. Like it's never in the production environment. It doesn't have like access to production networks, right? It's not part of the production VPN or any of its architecture. But it plays the role. It can play the role of a production machine.
Yeah.
Ish, and it was just a more precise word.
Yeah.
Thank you. That's really helpful.
It's really aesthetic, actually.
Yeah. I mean, I think it's very interesting because, again, like there's such a deliberate language in the Eventide libraries It's really helpful to understand the intention behind it because it is so deliberate. So thank you. Thanks for explaining that.
Environment isn't like a horribly overloaded term nowadays.
All terms are overloaded.
Yeah.
Yeah, okay. So just some final closing notes on all of this. Well, first of all, how were people's experiences with going through the TDD cycle and trying to, do those 3 laws that Bob says, only writing so much of the code that you need, only writing code when you have a test, those kinds of things. How was the experience?
Well, I think we've all done it, practiced it a lot in this room.
Yeah, I mean, LVT does it.
I mean, I'll just own up to it. This is the first time with the Eventide test I've done it that methodically. I typically copy a test and then I don't have those attributes, let me rename them. And it did give me a deeper appreciation of how the pieces fit together and learning the names of the writer substitute, because I definitely, I just view them as this whole. I don't actually process it as written. Just oh, that goes there. So this was good.
Then you switch to the fixture and you don't even care about it anymore.
That never happened.
Yeah. So that's something I'll say is when doing TDD, especially at first, it does slow you down, and you're going to do it poorly. For a while, you're not going to be great at it. It's a muscle that you have to train to get into the habits of doing just the smallest pieces, validating yourself as you go. And it takes a long time to get comfortable doing that, or not forgetting one time to go back and validate your tests and whatnot, or to always be predicting what your execution is going to be when you run the test and why it fails. Not just if it passed or failed, but if it's going to fail, why. So the Eventide repository or example repositories all show the testing like this, the way that I just or the one that I showed off, they do it like that so that you get comfortable and used to doing the nitty gritty of it, to understand what you're doing and why you're doing it. But they also provide something called Fixtures. This is something that you can add to TestBench, and you can add whatever fixtures you want. The Eventide people even wrote a blog that introduces a lot of the fixtures, and these I would implore you to go look at when you're feeling more comfortable with just testing Eventide components in general. They have a lot of built-in functionality into it that makes it easier to write a lot of tests really quickly. They do a lot of the tests under the hood for you. Like Casey was saying earlier, there's a danger to that if you don't know what the fixtures are actually testing for, you might use them improperly or poorly, which is why it's important to get used to testing it manually before relying on the fixtures. But they give a lot of good fixtures, and the blog that I have linked here on the slide gives you links to the documentation that Eventide also hosts that goes through what all of those fixtures are and how to use them. So that's just a little finishing note I wanted to leave you with for those who are feeling more confident.
I will throw out a note that some other libraries and things use the term fixtures differently. So it's worth going and reading that article and stuff to make sure you understand the TestBench meaning of fixtures.
Particularly if I learned the term fixtures from Ruby on Rails, and it's not even remotely the same thing.
Like how everyone throws around components.
Just go ahead and throw the link of that into chat as well, so everybody has access to it quick. And yeah, thank you all for coming.
Thanks, Scott.
Thanks, Scott. Sid, did you want to? Oh, you were saying thanks, Scott. Or did you have a question, or were you saying thank you to Scott?
Oh no, I was just saying thank you to Scott for doing this. Super enlightening.
Yeah. Cool. Yeah, Scott, thanks so much for presenting. I just want to for the first two, it was me, but this meetup is not meant to be the Ethan show. And so I'm really grateful to Scott for jumping in with a good topic here. So like that's open. If you'd be interested in presenting, talk to Casey or me. We're there in the Eventide Slack. And we'll be back again for Thursday of next month.
Sweet. It's because next month only has one Thursday. What?
What?
You said Thursday of next month.
The fourth Thursday.
Oh, I thought you. I was so confused. You're just
careful.
I'm sorry. I can't help it.
See ya.
I get nitpicky.